Discrete mathematics is a very important branch of mathematics. Now we start with unit number 2 of discrete mathematics, that is lattices and Boolean algebra. Now next is representation of Boolean functions, disjunctive normal form DNF and conjunctive normal form, that is CNF. Now mean term. A mean term of the Boolean variables x1, x2, xn is the Boolean expression of the form y1 meet y2 meet yn, where each yi is either xi or xi bar. For example, mean terms of the two variable x1 and x2 are x1 meet x2, x1 meet x2 bar, x1 bar meet x2, x1 bar meet x2 bar. So, how mean term is obtained? By writing the variables x1, x2, xn in the form y1 meet y2 meet yn, where either you have to take each yi as the variable itself or its complement. Now, disjunctive normal form of a Boolean function. If a Boolean function is represented by join of mean terms, then it is said to be the disjunctive normal form DNF of the function or sum of products expansion. Now, what is max term? A max term of the Boolean variables x1, x2, xn is the Boolean expression of the form y1 join y2 join yn, where each yi is either xi or xi bar. For example, max terms of the two variables x1 and x2 are x1 join x2, x1 join x2 bar, x1 bar join x2, x1 bar join x2 bar. Now using max term we define CNF, conjunctive normal form of a Boolean function. If a Boolean function is represented by meet of max terms, then it is said to be the conjunctive normal form CNF of the function or product of sums expansion. Now see this example. Find disjunctive normal form DNF for the following function. Now this is the function which contains two variables. So we prepare the table representing values of this function. As there are two variables x and y, there will be 4 rows in the table. And a column will be considering the right side, that is x, y, y bar, x join y bar, x meet y bar, and then x join y bar meet x meet y bar. Now while writing the DNF, we consider only 1 in the last column of that table. Now by definition, DNF is nothing but join of mean terms. So every mean term is nothing but meet of the variable or their complement. Now to get this answer 1, by the two variables x and y, both must have answer equal to 1. Now x is already 1 but y 0 here. To get it 1 we consider y bar. So that x meet y bar, that answer will be 1. So fxy is x meet y bar. Now there are no more terms because there is only 1 1. Now if there are more than 1 ones, then in that case then the remaining terms we join by join. Now, next example, find conjunctive normal form CNF for the following function. Now, given function contains three variables x, y and z. So, there will be 8 rows in the table. Now, prepare the table by taking columns according to right side. So, first 3 columns for 3 variables x, y, z. Then x join z and last x join z meet y. Now consider zeros in the last column of table for writing the CNF, which is meet of max term. Now meet means between two brackets we have to write meet, and max term is nothing but join of that variable or their complements. Now we get the value of join as 0 only if all are taking the value 0. So to get this value 0, if that variable has value 1, we take its complement. And if it is already 0, we take it as it is. So now here x is 1 and z is 1, so we should take their complement. So x bar join y join z bar, that answer will be 0. Similarly for this 0, if the variable has value 1, we take its complement. So it is x bar join y join z. Now for this Answer is 0. Now here y has value 1, so we take complement of y. So it is x join y bar join z. And similarly for last two zeros we get these two max terms. So meet of max terms is the required conjunctive normal form. So this is the end of unit number 2. Thank you.